Today we'll analyze an STL file. We'll begin by creating a new part file with units that agree with the units that we'll select when importing the STL file. If we're not sure, just pick one, and we can check after we import the STL file. If it's wrong, we'll just need to start over. So now we'll import the STL file. We'll select the STL file, the type of body that we'd like to create in NX, automatically clean up, and show an information window. Now here's where we're selecting the same units that we selected when we created our new part file. Now to check if our units are correct, I know this part is about 1.5 inches long. So here we'll orient the view in the plane of the work coordinate system, the XY plane, and take a measurement of 2 points that are next to the part, since the part doesn't have any points on it because it's an STL file. And there we could see it was about 1.5 inches long. So next we'll go into pre-post and create our simulation files. We'll create a linear static solution. And we'll begin by creating a mesh on our part. Now if we had selected the standard meshing method, which should be the default, what you'll find is a mesh that may not be satisfactory. So you can see, because we don't have any hard edges except for 2 in the part, we may get some poorly shaped elements, especially around the areas where we would expect to have a hard edge, but we don't have one because it's an STL file. So we'll go ahead and undo that, and we have a special meshing method for STL files, or facet files, which is to mesh from facets. This gives us a whole set of surface mesh settings which we can customize in order to get exactly the mesh that we want. And if you're wondering what those various items do, you can hit F1 for context-sensitive help and go to the surface mesh settings for meshing from facets. And you can see what each of those settings will do. So here I've set all of them. I've taken the default values for those settings, and we'll go ahead and create our mesh. And you can see how the element geometry is much better, and we've also got adherence to our sharp edges all around the part. So that we can get a model that will run, let's go ahead and assign material. The next challenge will be to assign loads and constraints. Typically you'd want to assign a load to geometry. However, because we have only 2 faces in the part, that's not going to work out. So we'll select nodes, and we'll use the smart selector to get exactly the location that we want using feature angle nodes. And here we have smart selector options to select the feature angle tolerance that we want. And then we can select one of the element faces, and it will go around to each adjacent element face that's within our smart selector tolerance of 30 degrees. So here you can see it does not go past those 90-degree angle edges. And we'll do the same thing for assigning a load in our other hole. Now we're ready to solve. And now that we have results, we can take a look at our displacement results. And animate them.